Okay, so yesterday we have seen state space, which is a set of nodes from which we have to go from a start node to a goal node. Okay, start node to a goal node. Using some search strategy. Okay, I have given you some example. So we have got two kinds of search. One is informed search. So what is the meaning of informed search? For example, a map, Google map. You exactly know the distances. So you know how much time you will get. You have some idea regarding the state of the highway. Okay. However, under certain situations, we do not have any information. So in that case, should go for uninformed search. Okay, just like suppose what career path you want to take, right? So that will be uninformed because you may not have all the information. Okay, you may not have all the information. So in that case, you intuitively use some kind of uninformed search. Appearing in a competitive exam, okay, you don't know exactly how much questions answer you know. Also, you don't know how much it will take for the questions paper to complete. So, whether you should go deep into a particular question or whether you should attempt more number of questions. Should you attempt more number of questions or should you attempt only a fixed number of questions and you try to correct them? So, which one is the better approach? Okay, so all of us know that it's always better to have more number of questions answered with some knowledge. Okay, so these are uninformed search. So in AI, as in humans, uninformed search are a major component. Okay, we do uninformed search many a times. Right, you don't have information. Many of you might have joined this university without knowing what exactly lies ahead. Okay. So today's class, only one class we will be doing on uninformed search, and in the lab, A1 students have did it, and other students, A2 students, you also, one class you should devote to uninformed search, breadth first and depth first. So these are the foundations of AI search algorithms. Okay, before we move into algorithm, you should know about how to pronounce it. Yeah, anyone? Computer science students, they use it. Okay, they know it. I think part of data structures or some paper, graph theory. Okay. Dijkstra. Okay. Dijkstra's algorithm. So he is a very renowned computer science professor. Okay. In fact, you can say that the whole of mapping, Google Map and all those things is based on his research. He was the pioneer in that area. So the first algorithm in that direction, it is actually on, there are both informed as well as uninformed version of that. Okay, but most likely it is informed. So it is an algorithm, Dijkstra's algorithm for finding the shortest path. For finding the shortest path between the nodes in weighted graph, which may represent a road network. Okay. It was conceived by computer scientist Edward W. Dijkstra in 1956. So the source of the Google map goes to long back to 1956. Computer science students, they do it regularly. But for us electrical engineers, we don't know about all these algorithms. Given a weighted undirected graph, a source vertex, we need to find the shortest path distance from the source to other vertices. So shortest path, isn't it? Google map always gives you the shortest path. Sometimes the shortest path may not be the optimal one. Okay. Sometimes shortest paths may not be the optimal one. It may pass through a forested area. Okay, maybe the road is damaged. Okay, or it may be a very populated area. So in that case, while using such maps, use some, what do you say, discretion. Okay. So even if Google Map is showing that this will be faster, ask people which road you should take. Okay. Because Google Map may not be knowing about the local conditions. But Dijkstra's algorithms only focuses on finding the shortest path. Okay. So everything else, especially the informed search part that you will see for next 4 classes, is based on this. Okay, he read about this. He is a genius, and you can find about how all his exams are subjective. Okay, for you it is not possible for a class of 90, but suppose there are 18 or 15 students. He used to take math exam in subjective manner. Okay, he used to have one-to-one interaction with his students. Okay. Okay. Next. So what are the uninformed search strategies? That means we do not have any information regarding the cost of the path or which direction we should go. So this is uninformed. Typical one is, what is your path after you graduate from here? What should you do? Since you are third year students, in the final year you will be more confused. Okay, such information is uninformed. Why? There are lots of information available. Your seniors will tell something, your parents will tell something, teachers will tell something, but actually you don't have any information. All this information will be contradictory. Eventually resulting is you don't have any information. So in such scenarios, what kind of search you should take? Okay. So these are the basic uninformed search strategies, also known as blind search, and uses no information about likely direction of the goal nodes. So you use some arbitrary scheme. Okay. You don't know what to do, just join whatever job you get through campus interview. In the next 3 years, you will figure out what is your actual requirement. Okay, so the most popular ones are depth first, which we do in our lab. I told you to download a program and run it and see the algorithm also. Iterative deepening, uniform cost, and bidirectional search. Okay, so what is the depth first search? So as the name says, it is a traversal algorithm that starts from a source node. And explores the graph level by level. Okay, a typical competitive gate paper. So in the first level, you don't go by giving too much time into a single question. In the first level, find out all the easiest questions from beginning to end, control system, control theory, whatever. Then in the next level, leave the questions you have left, try them again. And finally, if you have any time left, you can attempt the most difficult ones or the most time-taking ones. So such kind of thing is breadth first search. That means you first see the whole question to see what are the easiest questions that you can solve. Right? So that is the approach that most people who clear the competitive examinations. I am giving such examples because we are not from computer science background, so we did not go every time to all those toy problems of computer science, because our job is to apply these algorithms into some maybe electrical engineering domains. Okay. So first, you see, first it visits all nodes directly adjacent to the source. Okay, maybe you can think of, okay, if I am starting machines, let me complete see all machines questions. Okay, all machines and power system questions. So if I can solve them. Okay. After that, suppose you find which subject you find difficult, most difficult. How to cost math, power electronics. So suppose power electronics you find difficult, then leave all the power electronics questions, do it in the end. Okay, group together. Okay, all adjacent nodes. Then it moves on to visit the adjacent nodes of those nodes, and this process continues till all reachable nodes are visited. So you make layers, breadth layers. Okay. It starts at the tree root. Tree means, I have told you, a graph where there is no loop is known as a tree. Okay. It starts at the tree root and explores all the nodes at the present depth prior to moving to the nodes at the next depth. Okay. See. Okay, so it says that don't daydream. First find a job. More target ho civil services. Mu khali say out dekhi. Mojra which karbi. So that might result in frustration. Right? You start level by level. First get a easy job, do it, then increase your level. So that is how it is done. So that is breadth first search. Okay. In summary, it begins at a root or source node and explores all of its immediate neighbors first before moving to the next level. Okay. So you do your first level work. First you study for your semester exams. Then you study for the gate exam. Like that. Okay. Suppose just like this in your plus 2 level, if you don't read the NCERT books and you start attempting the JEE advanced questions, can you solve them? No, it's not possible. Okay. Even if you go depth wise, it's not possible. Okay, you have to first complete the textbooks. Steps. So what are the steps? Queues, linked lists, all are computer science concepts. We will take them as the intuitive concept, as we know. Queue, how a queue is formed? The one who is at the first. Okay, the one who came last will get to the end last. Okay, that is how a queue is formed. So initially is a queue. First in, first out. That means ये आगे आस्तेला से आगे पाएगा. So it is first in, first out. FIFO. Initialize a queue to manage the traversal. Start by adding to the root node to the queue and mark it as visited. Start with the initial node. Okay, visited. Traverse. Remove the node at the front of the queue. Look at all of its neighbors. First just ताको देख लो तारा neighbor गुड़ा भी देख दो. Okay. Repeat the process. So what are the applications? Shortest path. It optimally finds the shortest path or the fewest edges in an unweighted graph. Unweighted graph means you don't know the cost of the edges. That's an unweighted graph. Okay. Social networks. Finding friend of friends, degrees of separation, all these things. They use basically all this kind of search. Facebook को देखा है नहीं, friends of friend like this. Okay. Web crawlers. Search engines use it to index web pages linked directly to a home page. So they use it whenever required. Okay. So this is an example from this Geek for Geeks website. A very simple example. Okay. So you search it like 0, 1, 2, 3, 4. You don't go in this direction. Okay. This is a graph. This is not a tree. This is a graph. You go by exploring the nearest curves. Okay. This is simplest example. We'll see another example also. Then comes the depth first search. Okay. The depth first search means તમે gate exam रे electrical machines you are thorough, you only solve electrical machines. Okay, you don't go anywhere else. Okay. But as you know, if you go too deep into a particular problem, you lose contact with everything that is coming aside. Okay, we don't need depth of knowledge everywhere. Every time you go to a industry, we did not build a machine from the beginning. Okay, you just need to know your breadth of knowledge is more important than your depth of knowledge, except in some applications. Okay. So DFS explores a branch as deep as possible before backtracking. So first it will go into the depth. It employs a stack. Okay. Stack and queue, see the difference. Okay, search it when you go through it. It is the opposite of queue. Either explicitly or by the system called stack through recursion. Okay, steps. So what is the step? Choose a starting node or root and push it onto the stack. Make the current node as visited so that it is not processed again. Look at the adjacent unvisited neighbors of your current node. Pick one, mark it, push it to the stack to explore it deeper. Okay, you deeply you explore. If you hit a dead end, a node with no unvisited neighbors, backtrack. Outre feriasio. Popping items of the stack. That means last in, first out. Popping item माने तमें गोटे source को देखिला, put it to the stack like that. But eventually you go to the root of the node, end, depth. Now nowhere to go. So again, peel it back. Okay. So that is called popping. Push and pop. Okay. So this is one example of depth first search. So start at A, visit A. Move to its left child, which is B. Move to the left side, leaf node D. These are leaf nodes. Leaf nodes माने जोड़ा end रहते हो उसमें, leaf nodes. Okay. Explore the remaining branch from B. You pop it. Then you come here. So like that. So what is the BFS search? Konla A B C, so this direction. So this is the this DFS. भूल BFS लिख दीजिए. So this is DFS. Okay, depth first search. No, sorry. So this one is the route. Okay. A B D E C F. So this is the DFS route. Whereas in BFS we go A B C. A B C. Breadth first कौन हमें करिवा? A B C D E like that. So that is breadth first. Okay, so this is depth first. This is breadth first. This is very simple. Okay, algorithm I have given you. You can understand that. For the lab, you have to write the algorithm. Either print it or write it manually. But you have to write it. I have given you the algorithm. Lesson 5E. କରିଥିବ ଗୋଟେ extra ରେ ହେଲା algorithm. Those are from NPTEL courses. Okay, it will be from NPTEL course. So this is the state space. It is called the state space. So in that course, they defined one function known as moveGen. Okay. So what is the state space? Means all nodes you can expand. When you are in S, what nodes you can expand? The neighboring node को उड़ा. S पे खिला वाले. See, graph का देखो. S for neighboring A and B only, right? So उड़ा A रो हमें क्या चाहिए करिए? S and C, isn't it? From the start, you can go either A or B. Now, suppose you are in A, then where you can go? Either I can go C or I can go S, right? SC. Similarly, for C, it is either A or D or E. So, A, D, E, right? Similarly, if you are in D, where you can go either B or C or G, right? Similarly, if you are in E, you can either go to C or to go to G. If you are in G, you can go to E or D. So that means these are the whole set of moves that you can make. So that's why it is the state space. So these are the whole set of moves that you can make. That's why it is the state space. Now, if we apply DFS and BFS, we get a path like this. Okay, so these are the search trees for BFS and DFS. Okay, so I have skipped the algorithm which is there in that extra. You will find the solution there. So here, so this is how BFS explores, right? Like this. So the path found is SBDG, right? BFS SBDG. So this is the path found by the BFS. Why we lost all these nodes? Because those were closed. Okay, that you see in the detail. You see, we are not bothered about the details, only the principle. Okay. So this is the search tree for DFS. Okay, SACEG. So this is how the DFS obtain the path. Okay, or the solution. Yes. Now the question. Now the important point is the comparison between breadth first and depth first search. So we'll go through that. I told you in the last class we have seen we compare algorithms by means of several parameters. One is, are they complete? Complete means are they able to find the goal node every time? The answer is BFS, yes, always this is the goal. So if you do a breadth first search, you always lose the goal. DFS, no. Suppose, and that's why when you transition from 10th to 12th, you face a lot of problem, because in 10th the course is very less, so you can go deep to every subject. You remember, right? Score 95%. Okay, but when you skip to 12th, okay, then the course becomes very large. Okay, so if you want to do a depth one, then you lose the plot. Okay, so it becomes, you fall to infinite depth spaces. Okay, from here you cannot come back. Okay, next, time. So this is the time complexity notation, O notation. Okay, so this is known as time complexity notation. B to the power d. Okay, number of nodes generated, and here it is b to the power m. This much time you will take. To the power m, जितना थी वो तार to the power time you will take. It takes lots of time. It's not linear. Okay. Space. But if you see here, depth first search is linear space. We need only to remember a single path. That's why it is easier. Depth first search is easier. गोटे जिनसे को धरिकी ता भीतर पहुंचना is easier. It is more difficult to explore everything. Okay. Optimal. BFS is yes. So when you apply breadth first search, it is optimal. But DFS is not optimal. It may find the non-optimal goal. Suppose you get one question in your GATE exam or any competitive exam, and you say that no, I will solve it anyhow because I have read this subject. So eventually you lose the easier questions. Okay. So that's why you may not find an optimal goal. So in the GATE exam, the questions will be your goals. Okay. Right? Next. So after BFS, DFS, we'll go to a compromised one. Not compromised. Something with compromised. Compromised means the sky is compromised. Not that compromised. We'll go for compromise solution, means which is taking both BFS and DFS. So what you do is, rather than going deep, okay, you explore the depth at every level. Okay, that is known as iterative deepening. That means, okay, I'll go into deep, but first let me solve a set of questions. I go deep, and up to that level questions I solve. Then I go further. Okay, like that. It is an uninformed graph traversal algorithm that combines low memory benefits of depth first search. You need not remember many things when you do a DFS with the path optimality of DFS. Okay. Now remember that what about life? The life situations. The BFS na DFS ho. Samugra BFS. Okay. When I am taking your class, lots of things in my mind. So suppose I say that I'll only take class, I'll only teach. Is it possible? So university it's not possible. ତମେ କହିବ ହେଲା ମୁଁ ଖାଲି ପାଠ ପଢୁଛି ଆଉ କିଛି କାମ କରିବିନି. It's possible. ତମକୁ ବହୁତ କାମ କରିବାକୁ ପଡିବ ହଷ୍ଟେଲରେ along with your studies. Right? So breadth first search is how life goes. In fact, all problems are solved because there are several aspects to a problem. When you go to an industry, it is not like I'm an electrical engineer, you will focus only on electrical engineering problems. No. Suppose there is some device is malfunctioning or plant is out of service, and all staff sit together and find a solution irrespective of which branch you belong to. Okay. So breadth first search is more important. But depth first search is that it has some memory benefits. Like you need not, that also you have to do something. Suppose reading a book. Okay. So that makes you relaxed. You need not remember too many things. That makes you relaxed. A depth first DFS increases the depth limit by 1 in each subsequent iteration till it locates the goal node. Iterative deepening search systematically checks the search space by simulating a level by level expansion. So what we do depth first. We go into depth, okay, but we do a level by level. You clear campus interview first, get a job, then you go through different books to say study for something which requires more effort like a civil service. Okay. So level by level you do depth. Okay. First you have to reach somewhere. Okay. So it is very clear. I need not go through it. So every level you have to go one by one each level. Then you have to do a detailed depth search in every level. So that is known as iterative deepening. Exam re tamar kemti question asibo, since you are not computer science guys, so you won't ask problems in general. will ask you to compare these two searches. Uninformed search, suppose you are asked a question on uninformed search, you will be asked what are the various types of uninformed searches and compare with respect to the parameters, time complexity, optimality, like that. Okay. Difficult problems won't be asked for you because computer science guys, they have a head start. They know graph search and all those things. You don't have. Okay. Okay. So this is iterative depending. So as you see here, so first level 0, then level 1, 0, 1, 2, 4, then level 2, 0, 1, 3, 5, 2, 6, 4, 5. So level 2 re kon achi 0, 1, 3, 5, 2, 6, 4, and again 5. Okay. So every level you are going to the depth in every level. Okay. The next kind of search is uniform cost search. So we told that these are uninformed search. You don't have any information regarding the search. So under such situations, you may make some assumptions like that the costs are uniform. Uniform cost search is an uninformed search algorithm used to find the lowest cost path in a weighted graph. So it's a weighted graph. Okay, you have some weights associated with the graph. It expands the node with the lowest cumulative path cost, GN. First, like breadth first search, which measures the path length by the number of steps, treating all steps are equal, uniform cost search calculates the actual cost of traversing each edge. Okay. Edge one, the connection between two nodes. That's the edge. This is the edge. Okay. This could represent distance, time, fuel, financial expense. Okay. But here we assume them to be uniform. Okay. Next, steps konraila. Start at the root node, add it to the priority queue. Priority queue means you maintain the queue with priority. Just evaluate and expand, explore, update and repeat. So this is a uniform cost search. Okay. So here there are some costs given. Okay. There are some costs given. So the path is what are which path? A, B, D, G. Right, to goal node. Maybe this is the lowest cost path. 1, 2, 4. Total cost is 4 in this path. You take this path, it becomes 3, 1, 4, 1, 5. Like that. Okay. The simple cost search, uniform cost. Okay. The last one is bidirectional search. Okay. The last one is bidirectional search. So आप में देख लो breadth first search रे you expand your search space at a particular level. Okay, rather than going deep. In a depth first search, you go deep. Okay. Whereas in iterative depending, you go level by level. You go level by level. But there are certain problems, okay, where all of these may not be applied. So under such situations, you actually find the solution to the problem by the answer itself. For example, a proof. Suppose you are asked to prove something, right? So along with starting from the beginning and moving towards the proof, you also do a simultaneous calculation from the answer to the top. That means both top to bottom as well as bottom to top. So there are some problems, right, where we try to, this is also known as reverse engineering. Okay, you have a product, you try to find how it was formed. At the same time, you do a theoretical calculation from top. So wherever you meet, you now understand the problem. So that is known as bidirectional search. So what is the idea? So the idea for bidirectional search is simultaneously search forward from the start node and backwards from the goal node. So here you know the goal node. So in this case, you are very thorough about the goal node and you can do a backtracking. That means a proof kind of problem. Stop when both meet in the middle. Need to keep track of the intersection of the two nodes. So that should be, your mind should work, or the computer which is doing this must keep track of both these paths. Okay. Requires ability to generate predecessor states. That means, suppose there is a state, what was the previous state in both directions. So such information should be there. Now time complexity reduces by half, not by half. It was earlier b to the power d, but now it is b to the power d by 2. Okay, because you are traversing from both the direction. Okay, so whenever you face a similar problem where you have a goal clear, you try to find out the solution from the goal side also. Okay. Application. So in this case, GPS navigation system. Okay. Finding the fastest driving route between two specific match points. Okay. So from this direction, you know the path. From the other direction where you want to reach, suppose you have some prior information, I said predecessor nodes must be known. Okay. So from the other side, either someone must tell you, okay, don't मोर होनी पूरी जो पूरी को बहुत भिड़ जाऊँगी तो मझे आम पाक इनफर्मेशन आसेज आसटा तुम भुवनेश्वर जीव से मेसेज आस टाइम ऑफ वेटिंग इज नाउ 3.5 आवर्स एट आम जो मालतीपाटपुर रे वेटिंग टाइम हो 3.5 आवर्स डोंट कम टू पुरी रियल टाइम इनफर्मेशन आगर कौन होता तुम एपटू जाइए संबलपुर थोड़ा जो बारी गला सी भाई मुझे खुशी दर्शन करके आसवि बट he is unaware of the road conditions. He only knows the path, right, from this side. However, if he gets the information through his mobile that the waiting time at this location is 3.5 hours, then he can reconsider his decision. He may keep his own vehicle and may go by public transport, or he may drop the idea altogether, plan it for some other day, right? Okay, so that is known as bidirectional search. So GPS navigation system, puzzle solving, okay, computing solutions for well-defined combinatorial games like Rubik's Cube and 15 puzzle. Rubik's Cube is also, both types we are trying from, okay, this is intuitive. Okay, there are some problems we should solve from both sides, theoretically as well as from the other direction. Social network analysis, quickly calculating degrees of separation of mutual connections between two specific user profiles. Okay. Okay, so this completes our uninformed, uniform uninformed search algorithms. Okay. So there are 4 classes left in search algorithms where we will focus on informed search. Starting from next class, 4 algorithms will be there from informed search. Now we will have a discussion.